Welcome to the Unit 2 guided practice. This is part of your remediation practice, and we're going to walk you through and hopefully prepare you for your retest. Just going over some academic vocabulary, it says define the following terms. We have proton, neutron, and electron. Those three are what we call subatomic particles. They make up atoms. And so a proton is a positively charged particle found inside the nucleus of an atom. A neutron is a neutrally charged particle found inside the nucleus of the atom. And an electron is a negatively charged particle which is found in the electron cloud surrounding the nucleus. Protons and neutrons are relatively the same size, and then an electron is really, really small in comparison to a proton and neutron. The next part of the academic vocabulary is describe the following scientists' contribution to science. So, what were they most notably known for when it comes to the atom? So first we have John Dalton. Dalton was they call the father of the atomic theory. He proposed the postulates of the atomic theory, which were the very first beginnings of empirically tested to really show what an atom was. J.J. Thomson. J.J. Thomson was responsible for discovering the electron through the cathode ray tubes. And then Ernest Rutherford, the famous Rutherford Gold experiment, where he discovered the nucleus. And then Niels Bohr, who discovered the energy levels within the electron cloud, where we have our valence electrons on the outer shell and everything else. So, jumping into the atom, talking about protons, neutrons, and electrons, and it says describe what happens to an atom when the following particles are added. When you add a proton, that means you are adding a positive charge, and you are also changing the element. We know elements on the periodic table by their atomic number, and we call that the number of protons. So if we add a proton, we change what element it is. Okay, so if we have 6 protons, we know that we have carbon. If we have 10 protons, we know that we have neon. And so it just changes the amount or the substance that we have by how many protons we have. Now, a neutron, on the other hand, it's a neutrally charged particle. So when we add it, we're adding it to the nucleus. We don't change what it is, but we're just adding more mass to the nucleus. And this is really changing what we like to call isotopes. So by adding a neutron to the nucleus, we're changing what isotope it is. So we could have carbon 12, which has 6 protons and 6 neutrons, or carbon 13. It still has 6 protons, but now it has our 7 neutrons. It's a different isotope. And then lastly, we have electrons. Electrons are negatively charged particles. When you add or remove electrons, you are creating ions. It's an element that has a charge, and we'll talk more about that in a second. Moving on from this, it says using the information gathered from this section of the periodic table, how many protons are in nitrogen? So if you find nitrogen on the periodic table, remember the atomic number is the number of protons. Atomic numbers right there for every element on the periodic table. And lastly, it says what subatomic particle, proton, neutron, or electron, is the smallest in size. Remember, these two guys are relatively the same. Those electrons are really, really small. So, moving on into nuclear symbol notation. Nuclear symbol notation is just a way for us to basically express how many protons, neutrons, and electrons there are just by a simple notation. And so when we look at this, here we have 6 protons, we have 7 neutrons. So we add those together to get the mass number. So 6 plus 7 is 13. Okay, we put the atomic number on the bottom. That's the number of protons. 6. And then we look in the periodic table, and we can use this section right here. What has 6 protons? Carbon. So we put carbon right here. Now on these, we can check to see if we have an ion. We probably don't. But the way we figure out charge, which charge would go right there if we had a charge, we go protons minus electrons. So 6 minus 6 is 0. It's a neutral atom. We don't need to write the charge. Next one, we have 9 protons, 10 neutrons, so a mass number of 19. Number of protons, 9. We look on the periodic table. What has 9? There you go, fluorine. So we put an F. To find the charge, protons minus electrons. 9 minus 9 is 0. And then lastly, we see that we have our 18 and 22. So a mass number of 22 plus 18 is 40. Protons would be 18. We look in the periodic table. What is 18? That's argon. And the charge would be 18 minus 18, which would be 0. So neither of any one of those has a charge. They're not ions. Now an ion is, remember, it's an atom that has a charge to it. So on the first part it says describe how an atom could have a positive or negative charge. If it has a positive charge, that means it's going to have more protons than it does electrons. Now, you cannot add protons to an element to make it positive, because if you added protons you change what the element was. But what you can do is you can take away electrons. So if you lose an electron, you become more positive. If you gain an electron, you become more negative. So how do you create something that's negative? You gain an electron. How do you create something that's positive? You lose an electron. So on B it says write the nuclear symbol notation of the atom that contains the following subatomic particles. It says write charge if necessary. 6 protons, 7 neutrons, that is 13 for the mass number, 6 for the number of protons. It's carbon because it has 6 protons, and all we do is protons minus electrons. 6 minus 5 is 1, so we put a plus 1. And then moving on to C, we see that we have 11 protons. It has a positive charge. So what does that mean? That means that we have one more proton than we do electrons. So we can say we have 11 protons. Neutrons, 12 minus 11 would just be 1. And then our electrons, we have our charge is plus 1. And we know that we have 11 protons. That means how many? It's protons minus electrons. How many electrons do we actually have? That means we're going to have one less electron than we do proton. So that means we're going to have 10. On the next one, it says determine the number of valence electrons in the following element. When we're looking on the periodic table, it's really nice. Group 1 is 1, group 2 is 2, 13. Take away that 1 right there. It's 3, 4, 5, 6, 7, and 8. So when we're looking on the periodic table, we can just look at that. So on this one where it says write the number of valence electrons, when we look at nitrogen, nitrogen is group 15, so it has 5 valence electrons. Oxygen is 16, it has 6 valence electrons. Potassium is in group 1, so it has 1 valence electron. The next one, it says write the correct electron dot notation for sulfur. So we need sulfur in the middle, and we need how many valence electrons it has. And it's going to be, if we look on the periodic table, sulfur right here, it's in 16. It's going to have 6 valence electrons. So we go ahead and go 1, 2, 3, 4, 5, 6. And we have our 6 valence electrons. That's its electron dot notation. And last one, we do it for sodium, which is Na. It's going to be in group 1, so you put 1 dot.